So we ended the last video with this example of El Dorado Community College. And you notice this is a little different from transforming random variables or transforming a distribution because you're multiplying or adding or subtracting when you transform it. If you're combining random variables, what you're looking at are two separate situations combined into one. So in the first situation, we had the campus, downtown campus, which you can only take in multiples of three unit classes. And down here we have the main campus where you can take anywhere from 12 to 18 credits to be considered full-time. And so we added the means together to find out that the expected, if you selected a random student from the downtown campus and you selected a random student from the main campus, you get approximately 30 credits between them. So this is what we call combining random variables. All right. So basically you just add the means together. If you have two random variables, and we usually call the first set X and the second set Y. And then T would be the total, or the expected value of this event labeled T. And so another example would be housework. So if you're thinking of the weekend, you can imagine that it takes you 1.25 hours on average to vacuum, and then it takes you about 0.45 hours to do laundry. About how long would you expect it to take you to vacuum and do laundry? I mean, common sense, you just add those together. And I believe it comes out to being, let's see, 1.25 plus 0.45. It comes out to being 1.7, or 2 hours and about 10 minutes, right? So go ahead and try this example. Remember we actually calculated the mean and standard deviation of this auto dealership for cars sold, but now we're adding on a second random variable, and that is Y, which is the number of cars leased. So this is the probability of leasing a car within the first hour of business on Friday, and these would be the probabilities of selling a car within the first Friday. So go ahead and pause this video if you want to maximize your practice time so that you can do better on the test. So essentially you're studying right now. And answer these three questions to the best of your ability. Okay, so welcome back, and let's go ahead and go over those answers. So in the first situation, what you just needed to do was add your means together, and you should have gotten about 1.8. So over many Fridays, the dealership sells or leases about 1.8 cars, so about 2 cars on average on Fridays after the first hour. So the second situation was a little bit different, and we haven't technically learned this yet. So you can't just add your standard deviations together to find the total. You can do that for the mean, but for the standard deviation, hopefully you just added these two together to get your total. So you're learning something new here. You actually have to first calculate the variance. And from the variance, you can calculate the standard deviation. And please remember the variance is just the standard deviation squared. So there's one extra step for standard deviation. You square it, add the squared values, and then take the square root of the square values. So give or take one car, 1.14 of a car, that's about how accurate your average is. And then in the third example, okay, where am I going here? In the third example, please remember that you're multiplying the situation labeled X, cars sold, by 500, because that's how much the auto manager makes, and you're multiplying the leased cars by 300. And so you're just going to go through and do the same situation. You're going to take your mean values, multiply them by 300, add them together. And because X and Y are independent, now you actually have to take everything and square it. So you distribute squaring, which you should remember from last year. So 500 squared plus the standard deviation squared. 500 squared times the standard deviation squared plus 300 squared times the standard deviation squared will give you your total. And then you take the square root. So on average, that's pretty good money. this auto dealership manager is expected to make about $509 on that first hour on Friday as bonus. So that's pretty good money. Okay, so that's adding together to random variables. But now we're going to talk about what if we want to find the difference between the two. And so in this case, order is important, so you have to be very careful on how they define it. So if they're saying the difference of x, take away y, you make sure you put x first, the mean of x first, and the mean of y second. And simply because negatives come into play when you're talking about differences. And you want to make sure that you're doing that correctly. And then, of course, you need your rules for variances, because in order to calculate your standard deviation, you need to go back and calculate the variance first. And so as you saw when it was 500 times the standard deviation, of course we had to take the 500 and square it plus the standard deviation squared, or times, I'm sorry, I don't know why I keep saying plus. So it was 500 squared plus the standard deviation squared. And moving on. Now if they're independent, it doesn't matter if you're finding the sum or difference of your standard deviations, you always add. Okay, so these are just rules you have to memorize. And again, it's hard to determine why. The reason why you don't ever take a difference is because, remember, variance is the expected value minus the mean squared. And when you square it, you're always taking away the negatives. All right, so let's look at some simple examples. If I was given independent random variables with the means and standard deviation shown here. So this is situation or random variable x and situation random variable y. Okay, and I want to find 3x. Well, to find the mean, I just simply take x times 3, which is 30. And to find the standard deviation, it's just 2 times 3, which is 6, right? And these are independent. We're not looking at multiple distributions here. We're looking at one. If I were to take y plus 6, again, we would just take 20 plus 6 to find our mean. And because we're adding, our standard deviation is not going to change in this situation. So for this one, we would get 26 as our mean, and our standard deviation is actually going to stay at 5, because the standard deviation only changes when you multiply or divide. But in this case, we had 30, and our standard deviation was 6. All right, now we're going to talk about what if we add them together. So now we're adding our means together. So this would be 10 plus 20, which is 30. And for the standard deviation, we've got to take 2 squared plus 5 squared to find the variance first, and then take the square root of that. So I believe that's 25 plus 4, which is 29. And so the answer would be the square root of 29, which you can go ahead and type in your calculator. And again, x minus y, this would be 10 minus 20. So you can see here why order is important, because we're going to actually get our mean value of negative 10. And then for standard deviation, again, it's going to be the same here. Standard deviation is going to just equal the square root of 29, whatever that value is in decimal value. All right, here we go. This one's more complicated. This time we're going to multiply x by a factor of 0.25, and we're going to add it to y. So it's the same situation. You're just going to quickly take 2.5 times 10 plus 20. So that's 2.5 plus 20, which is 22.5. So that's our mean. Now for our standard deviation, you're going to take 2 times 0.25, which is, I believe, 1/2. Yep. So this would be, or you could do 0.25 squared times 2 squared plus, I forgot we have to calculate variance first, 5 squared, and then you would take the square root of all of that. So second, square root of 5.25 squared times 2 squared plus 5 squared. And I got 5.02. But I'm going to go back and double check. Yes, you should get 5.02 if you're rounding. 5.02. Awesome. So that's how we do that. Go ahead and try this example. Again, work it out on your own. We're going back to that same auto ship dealership. This time, though, instead of knowing what their total bonus is, we want to know the difference between the cars sold and the cars leased. So after you worked these out, you should have noticed that originally you just take the mean of x minus the mean of y, and you should get a difference of 0.4. So this dealership sells about 40% more cars than it leases during the first hour of business on Friday. And so because x and y, we're always assuming they're independent, we're going to square the values and add them, because it doesn't matter if you're subtracting, finding the difference, or finding the sum. You're always going to add for standard deviation, and you still get 1.14, which is the same. Now you're going to do the same thing, except for here you're going to have a minus sign in between instead of an addition sign. So your mean, you just plug in your mean values, multiply it by 500, multiply it by 300, and subtract. But for standard deviation, remember, you have to square the values, find the variance first because they're independent, and then you're going to add the values. And so again, you should get about $509. It's going to be the same value as before because you're calculating the same thing. All right, so this is the last part of this video. I would like you to try 3 problems on your own. You can pick 3 of these 4, either 42, number 50, 52, or 56. Do all 4 if you want extra practice. That's excellent. And then on the next video, I'll show you the answers to these 4 problems. If you have any questions, raise your hand. I'll come around and help you.